All right, so now we have our last panel of the day, which is our robotics panel, and I've got the pleasure of moderating it. And we're going to spend an hour doing that, and then we'll wrap up with Jamais. So let me briefly introduce each of our panelists up here. Trevor, are you twittering? No? Okay. And then after I introduce them, we'll have each of them spend a few minutes telling us about their companies or concepts or things that they're focused on before we dive into all the great questions. Immediately to my left here is Chetan Kapoor. Chetan is a entrepreneur, CEO of a company by the name of Agile Planet. And Agile Planet has technology that Chetan developed while he was a professor at the University of Texas at Austin, and has gone through a technology transfer process with that software that he has created, and I'll let him explain some of the focus on that in a minute. Next to Chetan is Trevor Blackwell. And Trevor runs a hardware company here in the Valley called AnyBots. AnyBots has some very interesting robotic development activities going on. Originally some anthropomorphic robot focus, and now in the telepresence robotic space, which he'll tell us about. Next to Trevor is Dan Kara, and Dan is a familiar face in the robot community as he runs the largest robotics research and events company called Robotics Trends. They put on an annual series of robotics events, Robo Business Symposium, which was in Pittsburgh this past spring, and the Robo Development Conference, which will be next month here in Santa Clara, I believe. Yep. Right? And I'm speaking at it, I guess, right? So I better know where it is. And then on the end is Bruce Hall. Bruce is the president of Velodyne, and it is actually Velodyne, the speaker company that you may be familiar with, but Velodyne LiDAR is a spin-out technology company that has emerged from those guys, and next to him is one of his cool sensors that he's going to tell us about. So let's let Bruce go first, and we'll come back down this way. Bruce, tell us about your company and your concepts.
Thank you, Jonas. Can you hear me okay?
Yep.
We're based down in Morgan Hill, and as Jonas said, by day we make high-performance audio subwoofers for home theater, and you would find our products in places like Fry's and high-end custom installs, like in Robin Williams' house. We just celebrated our 25th anniversary of that business, so it's a solid up-and-running business. We export to lots of countries and sell in all kinds of stores here in the U.S. By night, we dabble in other kinds of technologies, and about 10 years ago, we started to get into, of all things, fighting robots, because more than anything else, we wanted to get on TV. So we went into BattleBots and Robot Wars and Robotica. If any of you remember those shows, we participated in those. Those died out in the early 2000s and gave way to a series of robotic autonomous vehicle races called the Grand Challenge. And those were sponsored by DARPA, which is the Defense Agency Research Projects Agency, the company that actually claims the invention of the internet. And they decided that autonomous vehicle development was not moving along fast enough. So they conducted a race similar to the X Prize, if you know that race of space vehicles. This was for autonomous vehicles, and they held up $1 million and $2 million prizes to teams that could put together an autonomous vehicle and have it make it from point A to point B across primarily a desert course. So there were 3 races conducted so far. We participated in the first 2 with our Toyota Tundra. Didn't win either one, but we did develop some interesting technology for the second race, which involved laser sensing. And if you want to build an autonomous vehicle, you have to teach it to, number 1, follow a course. In other words, go from point A to point B and not hit anything. And number 2, have enough sensing technology that it can know where it is and what's in front of it, where the flat road is, and don't bump into anything else or another vehicle. So we originally did the latter challenge with cameras and decided that active LiDAR was the right way to do it. When I say LiDAR, That means issuing a pulse of light through a laser diode, having it bounce off something and detect when it returns, measuring that time of flight, and that becomes a pixel, right? So the way that people had done this before is they would take a single LiDAR pulse, they'd fire it through a mirror, and the mirror would spin, and you'd have this single plane of data, like this little slit of data. And it wasn't enough data to navigate by. And I think one of the overriding themes of sensing that we'd like to point out is that there's not enough data in general to navigate properly. You need more information about the world around you to navigate. So we came up with a sensor that uses 64 lasers. Don't ask me where that number came from. It just seemed like a good number. And we spread them across a 26-degree field of view, and each laser fires about 21,000 times per second. So the entire unit spins, and that's this unit here, sweeping out this data, and then you have this 360-degree point cloud based on pixel data, right? So you have these distance data points, and so your computer and parsing algorithms can now look at objects like cars and walls and poles and know exactly how far they are and what they look like, unlike trying to extract that information from video technology. So we made a prototype of this in the second race, which was 2 foot in diameter. We called it the spinning wheel of death. Many people were very interested by it, and DARPA came to visit us and essentially based the third race on our sensor. And so we shrunk it down to this size, which is about 8 inches in diameter. We call it the spinning dreidel of death. And so we sold these to all the teams that participated in the third race at full price. So you don't see our logo anywhere because we didn't sponsor anyone. We sold them all sensors. And we were lucky enough, the third race was conducted, this was the urban challenge where you actually had to drive in traffic. And these are completely autonomous vehicles, no remote control, none of that. So we were actually on 5 out of 6 of the finishers, including the 2 winning teams, which was Stanford, or Carnegie Mellon won it, and then Stanford was second. So we were very lucky, got a lot of exposure there. That has led to a business where we are selling these into lots of research organizations. People are using them for autonomous navigation and onto things like mapping. You can count on the fact that in probably 3 to 5 years, all the maps that you see will be in 3D somehow, as they are now in Japan, and people take this amount of data, they turn it sideways and collect this huge amount of data as they drive down the road. So all these different markets are opening up. There's a lot of emerging technology that's coming along, so that's why we've actually spun out the LiDAR business to make it separate. So that's what we do now. Thank you.
Okay, Dan, why don't you tell us about your company and some of your observations in the space?
Well, the company is Robotics Trends. We're an integrated media company out of Boston. We follow the classic Boston integrated media company. We do market research and consulting. We put on events, and then we also have publications. Robotics Trends is the online publication some of you might be aware of, and there's some other media products that are coming out. We focus on the personal service and mobile robotics industry, and also some of the industrial robotics industry now as they're kind of coming together. We focus it from a business standpoint, so there's no hobbyist stuff there, there's no things about people making movies with robots in there. It focuses on people who are looking to build robots, partner with companies to build robots, invest in robotics companies. In terms of market research and consulting, we work typically with international business development groups or international companies looking to bring products into North America or vice versa. So what we are basically is a facilitator for this whole new industry, which is mobile robotics and intelligent systems. And I'll leave it at that and take the follow-up questions later.
Great. Trevor?
So AnyBots, which started about 7 years ago, to try and build what we think are the interesting class of robots that are going to be possible in the next few years. And the new class of robots, which basically haven't existed before, are robots that are roughly human size and roughly human shape, and the point of them is to interact with people. There are, lots of great robots that are very good at interacting with parts on assembly lines or interacting with carpets and with physical things, but there just are not yet really useful robots for interacting with people. And that's what we spend most of our time doing, is interacting with people. And so having robots that do this is going to be a big thing when it becomes possible. And where it gets really interesting is when you have a robot that can interact directly with people in that kind of physical space, And we have a network already that's fast enough to control a robot like that anywhere in the world, from anywhere in the world. And so, you know, it's now going to be possible to send a robot into some remote location and drive it around and interact with people almost as if you were there physically. And you know, and that becomes quite a lot better than video conferencing or any of the and certainly a lot better than being on a speakerphone for interacting with people. So we're working on that. We're going to show something at Consumer Electronics Show in Vegas in January that we think is going to be interesting.
Are there any specific verticals that you think might be better than others? Medical, manufacturing, defense?
Those three are moderately interesting, but actually just you know, business people talking to other business people is what a large fraction of air travel is done for. And you know, so if I mean, currently in order to have a proper meeting with someone, you have to, you know, book a plane flight and get on a plane and go have a you know, spend a few hours talking with them and then fly back, and that wastes your entire day. So you know, the opportunity there is huge. And you know, as the world gets supposedly flatter, as you know, as more things are done in China or Europe or somewhere reasonably far away, that becomes more and more interesting. But yes, I mean, there are lots of reasons to send a robot in to do something instead of you going there yourself. So I mean, the thing I've been talking about is that it's a nuisance to fly places. But dangerous environments are certainly the other one. I mean, there are a lot of people in Iraq who are not there to actually hold a gun or, you know, do anything physical. They're there to communicate with other people. And so I think it's not going to be that long before they're sitting in a comfortable office in Washington or you know, somewhere, and doing that through a telepresence robot.
Thanks. All right, Chetan, tell us about Agile Planet.
Well, thanks, Jonas. Agile Planet is a year-old company in Austin, Texas. It's a spin-off company out of University of Texas. And our play is to actually provide platform technology in robotics, which is focused on safety. What you hear today is, you know, robots possibly that can provide telepresence, that can probably do manipulation also in the human world. And before any interaction occurs with a human for a robot, you have to guarantee a safe system. And so what our focus is to provide some core technologies with which you can build robots that are safe. And our target markets are manufacturing and medical. And we have customers in both these areas. Medical is very promising for us. There's always a patient involved. And if there's going to be any robot or any device like that in that space, it needs to be guaranteed to be safe. Its motions are supposed to be safe. So it has to have a certain amount of sensing and a certain amount of intelligence to do that. And that's really what we are up to.
So you're a software company.
Yes.
And a software company that's focused on the robotic middleware vertical,
Exactly.
essentially.
It's a middleware.
Right. And then down at the end, we've got Bruce, who's a sensor company that happens to be particularly focused on, you know, a emerging robotic space, the autonomous vehicle or data acquisition with vehicles kind of space, I guess. Although from a sensor perspective, you don't necessarily have to be affiliated with a robot, right, Bruce?
No, but we do focus on the mobile aspect of it. So
Right.
we design products that are presumed to be moving as they do their data collection, which speeds up the process.
Right. And then we've got Trevor, who actually is making a robot. And all three of you have different interests in acquiring capital to make your businesses more successful. Trevor, just by way of introduction, also runs an incubator, or is part of a partnership for a local incubator here called Y Combinator that some of you may have heard of as well. So he's pretty familiar with getting things started up. But my question to the three of you is, what is going on with trying to get this space funded? Is anybody getting any money, and what are they getting money for?
I can talk to that if you
Yeah,
want.
go ahead.
Well, a lot of most of the time when we sell, in fact, all the time when we sell, it's to the emerging technology group. What does that mean? They've seen the sensor, they think it's cool. Gee, we got to find a use for this thing somewhere, let's buy one. That's how it works. So we don't have right now a vein of demand that has said we're going to take the image that this collects and carry it through to an end user vertical application, except in one or two exceptional cases that I'll cite, which is basically some road mapping. If you want to talk about slow-moving autonomy in small vehicles, that's a market that's going to be there in 5 years. If you want to talk about a lipstick-size sensor that does everything this does, you know, that's what the car companies want. In fact, they just told us that last week. We're 3 or 4 or 5 generations away from that, right? This is $75,000, so we're just a few generations away from providing that. And by the way, behind that, we need a whole bunch of embedded technology to parse the image and make good business decisions about driving, right, and add safety to it. So the cycle times for trying to monetize some of this or make it fungible are in the 5 to 10 to 15 years, unfortunately, for a lot of these markets, and you have to watch out for that if you're investing. And for us, we're looking around for where's the short-term hit. And this 3D mapping appears to be one of the most immediate and good opportunities for us, because if you look at 2D maps, they're pretty boring, and 3D maps are really exciting. If you go to Japan, they're almost all 3D maps now, and they're very cool. So that, to us, is a market that has emerged. The way we're getting funded, more than venture funding, is we are partnering with large partners who recognize these development cycles and are part of them. And they want to lock us up, because they don't want their competitors to have this access to the same technology. So the way we're going about it, more than anything else, is either through exclusive licensing fees or other types of deals that give them access to the technology as we work together to cultivate the market that excludes competitors. So that, more than anything else, is how we've been doing it.
Dan, did you have an observation about what you've seen across the industry?
In terms of investment?
Yeah,
Yeah.
or lack of that thereof.
Well, the robotics marketplace is very, very large and very, very fragmented, going all the way from, say, multi-million-dollar autonomous vehicles all the way down to sub-$100 toys. So it's difficult to talk about the whole thing. On the high end, that stuff is already handled through primary contractors for the DoD. But in terms of investment, the type of investment I suspect most of the people here are involved with, VC type of investment, what people are looking for in the VC community and where people are getting funded is not so much for whole cloth robots as opposed to low-level enabling technology, technology that can be applied to a variety of robotic types. So what people are going out for and looking, and they tend to map to overarching themes in the robotics industry. Probably the biggest one now is autonomy. So whether it's localization autonomy or power autonomy with batteries, those types of things are drawing a lot of interest, as opposed to, say, robotics companies, unless they're tied in with a very specific vertical market segment or they're tied in with a really great idea. So, for example, a robot that just does knee surgery out of Florida, I think it's Mako Robotics or Mako Systems, that type of company gets funded because they see the demographics, it does something really well. But other than that, it's mostly the underlying technology, the technology enablers across multiple robotics types.
Chetan, I know you've worked with companies like Mako. Yeah. How about the software space? Are there robotics software plays that are getting funded?
There's a couple I know about in the autonomy space that have been funded. Outside of that, it's pretty hard to say to the investors, say, give me money so I'm going to create a middleware and robotic software that I can sell. What they want to really hear is, in our case, is a specific application that you're hitting with, either with a device or with software that is for that application. And that's when I get attention from a VC. However, we do find customers for our kind of technology in medical and manufacturing both. And we are seeing some traction there. So I'm hoping to prove the VCs wrong a little bit, you know, that there is a place for a middleware like that. But I agree, there's outside of a specific application, I haven't seen much funding in robotics. There's DoD applications, but that's a whole other area where the DoD is funding it.
Trevor, like I said earlier on, you've had your hands in funding a bunch of startups over the last couple of years with your incubator. How does that cross with the robotics space, or does it at all?
It doesn't very much. The model for Y Combinator is relatively small amount of funding and a lot of kind of hands-on working with them, connecting them with people. Small amounts of funding, meaning on the order of $15,000 for enough for 2 or 3 guys to rent an apartment for the summer and build a prototype, that they can then take to next stage investors. In general, in the robotics space, there is not much you can do on that scale of time and money. You can definitely get a web consumer application off the ground on that, but anything involving robots seems to be an order of magnitude more expensive than that. And I mean, there's a good business as Velodyne's finding, and that there are now enough robotics projects underway that if you can sell a $50,000 thing to each one of them, that actually starts looking like a business. So that there are real businesses in the sensor and component parts of robotics.
Okay. I'd like to go to the audience fairly soon here, because I'm sure there's in each of these panels, there's been lots more questions than we've had time to address. So start thinking about questions after we do the next series. I'll wander out there with the microphone if there are questions, and we'll try and take a lot more input from the audience on this. But the kind of next question I have for you guys is, put yourself and your company out 5 years from where we are today, and tell us briefly about your industry and what is state of the art then. What are people going to be doing, Chetan, for example, in the robotic, how are they going to be using middleware in the medical space? What kind of robotic centers do you see out there on the horizon that will be, saving lives?
Well, I see significant developments in robotics in the medical space, both in minimally invasive surgery, which has already been pretty provenly successful, in orthopedic surgery, and also in radiation treatment for cancer. All of these 3 treatments require robotics and can benefit from it. Now, there's few players in these areas, very few companies that are doing it. Mako Surgical is one, Intuitive is another one, Accuray is another one. And there's a lot out there who are wanting to get into this space and use robots. Here's the biggest barrier that they face today. I need a safe robot. I need to certify my software. And that'll going to take me 3-4 years to get to market just doing that stuff. So what we expect is that with our technology, enable a lot more companies that are getting into medical devices and specific treatments to jumpstart their development. So that's what we are looking at. And what you're going to see is, right now, there are robots that are very constrained in their performance of whatever they're doing. Very little performance, okay? It's just a little bit better than what a human does. To really get to the full potential of robots and really make throughput in medical, they have to be safe and high performing both. And that's really what you're going to see. You're going to probably end up, if somebody's getting cancer treatment, you might end up in a place where there's a couple of robots hovering over you, moving around almost like this, doing radiation treatment and sensing where the tumor is so they can be very precise. Instead of move you, robot does this, move you, come back again next day. It might be almost like a choreography of robots around you to do that. And for that to happen, that is where the safety and the motion planning aspects come in. And that's really where I see 4 or 5 years down the road as a distinct possibility that'll be the case.
You were telling me, and I don't remember if you would, or if you're able to say the name of the companies that are doing this, but you were telling me that there is at least one company that is building these surgical suites, these radiation centers that cost like $100 million or more, that they're outfitting with automation, essentially, to...
Yeah, this is a company, $100 million cancer treatment centers, and their first one goes live in June, and they're using robots. And their whole business model is built on one thing: X number of patients they have to treat in a day. If they don't, it doesn't work. And the only way they're going to do it is with robots.
Right. Bruce, we've seen the auto industry crater here big time, and go asking Congress for a bailout and getting their $25 billion. We've seen a lot of focus, a lot of hype in the auto industry about alternative fuel vehicles and electric vehicles now with the GM and Chrysler and everybody talking about the plug-in cars. 5 years from now, is there going to be anything that has value on an automobile related to sensors that's going to make your driving experience any different?
I think so. By the way, we went out and visited a prominent car company, and that day they were having layoffs. So it was a pretty depressing meeting, all things considered. The challenge for a vehicle, if you want to enhance its safety systems, is to figure out where it is. And if you know where the vehicle is at all times, you can do things like predict a sharp curve that's coming up. You can warn someone when they drive off the road. You can stop them from going into an intersection where there may be danger. There's all kinds of benefit to localizing the vehicle. The problem is GPS, which is the most prominent technology to do that, is not reliable enough to do it and avoid lawsuits. So the car companies are stymied in this localization challenge, and so they need sensors to help them do it. So the question is, how will the sensors evolve to let them get them on production vehicles to assist in this localization? And if they can figure that out through technologies such as the evolution of radar, the evolution of more tactical type LiDAR sensors and others, then I think you'll see some significant advances. They know how to do it, they just don't have the sensors to figure it out. But in 2002, they knew what to do, and they've done none of it today, essentially. I mean, they've got a few things like some parking lot maneuvers, like self-parking in the Lexus that doesn't work, by the way, and autonomous cruise control that's sort of better than your own ACC. They're making very, very small strides, but their problem is they don't really have the sensors to do it, and they can't deploy them until they cost $100. And you're multiple generations away from that. So I'm afraid it's going to be a while before we see some significant improvement there, and then it's going to come all at once. Then they're going to really be great. Like you'll never die again in a car. Like that's the idea. So that's kind of how I see it, and maybe it's not that dire, but I see it going that way.
Can you bring up there you go. Let me open it up for anybody who has a question for the panel back here. We'll start back here.
There's a lot of activity going on today with military applications for robotics. I was wondering if you could comment on some thoughts regarding the ethics of autonomous robotics systems that are weaponized, and how you view that as an industry or as a company in that industry.
The efficacy of these robots?
The ethics,
ethics.
or the ethical questions. For example, the efficacy, I guess, is a different question. But the ethics of autonomous robots that are armed and weaponized. And for example, if a robot kills a human being, who's responsible?
Can I, if you guys?
Yeah.
So we talk to the military a lot, and I think one of the areas where autonomy is going to evolve more quickly is in slow-moving autonomy. When you talk about, Jonas asked about the automotive industry, that's what I call fast autonomy. You have slow autonomy in things like lawn tractors and slow-moving carts that carry soldiers' weapons, right? There's this transport vehicle that follows the soldier wherever he walks and carries his stuff, right, automatically. And I think first of all, there's a mandate in the military that says no ordnance will ever be delivered until a human agrees that it will happen, okay? So, and that's not going to change anytime soon, probably not in our lifetime, that you would have an automated way that a machine will decide to kill someone, okay? And I think that's really kind of the doomsday, the RoboCop scenario that we all fear, that all of a sudden these machines are going to run rampant and shoot us all. Well, the military is a long way from letting that happen. So the way we look at it is to say, number one, more often than not, the type of vehicles we're being put on are not ordnance-carrying vehicles. They're either the cargo-carrying vehicles or other types of things. And number two, if we do provide technology that helps a soldier be more efficient, if we take a soldier out of a cargo van, for example, and we create a leader-follower system, and that soldier is not in harm's way, well, guess what? We just saved a life, because we don't have a kid driving down the road getting hit running over an IED. The car is driving itself. So most of the technologies we're seeing in the military are not intended to increase the efficiency of how we kill people. They're designed to either get soldiers out of harm's way or increase the knowledge that you have so that your ordnance is delivered more intelligently and more tactfully. I hope that's
I can follow up on that, and actually, it's not even our lifetime. There's no plans at any time to have an autonomous, basically someone not on the trigger. The military has made that very, very clear, and in fact, they are showing, if you, I don't know if you follow the industry, but about a year ago or maybe 8 months ago, they had an unmanned ground vehicle made by Foster Miller. It was weaponized, and it was being launched, and they're promoting it out in Iraq and all the rest of it, and then it just went away. And the reason that it didn't get deployed, because they just weren't sure that it was accurate enough or whatever, and they know, the military knows, if they screw this up one time, it's all over. It sets them back 20 or 30 years. So they're being very, very careful about that aspect of robotics.
And you know, the Geneva Convention rules and all those, they're written for human soldiers doing things. And that's another aspect. They don't know what's going to happen with that. So I agree, nobody's really touching that yet. And if they decide to do that, Agile Planet safe robot chip will be on that robot and prevent it from doing it.
They'll come to you. Okay, and not everyone has to answer every question on the panel because there's quite a few hands up. So here's the next question.
Hi, Stephen from Roborealm. A question concerning the industry. If you look at it globally speaking, it is quite clear that the Far East, Japan, Korea have sort of exceeded the US in terms of robotic industry, robotic development. Could you comment a little bit on what they're perhaps doing correct or at least better than what the US is and what the US needs to do in order to catch up to them? Thank you.
Well, I think they're putting more money into it is the high-level answer. You know, Honda has been working on walking humanoid robots for, I think, just about 25 years now. Spent well over $100 million on it, and they've gotten somewhere. And nobody in the U.S. has spent anywhere near that money, and so they haven't gotten anywhere.
I can follow up with that. I mean, there is this conception, particularly in industrial robotics, because they were invented here and went over there, that the U.S. is behind, or North America is behind Asia, or in Europe's behind Asia. That's not necessarily correct. I mean, if you talk about, say, security or military robots, it's not even close, or even medical robots and other types of automation in that area. What Japan and Korea primarily do better than us is that they not only just fund with pure, outside of pure research, they fund things to be commercialized. So here in the US, we do get funding. It goes through DARPA or it goes through pure research at a very high level for things such as autonomy. What they don't focus on is actually working with a university, a large organization, and an entrepreneur, and bringing those together with government funding to build commercial products. That's the difference. Here, we get our commercial products through typically a VC chain or something else, and the DoD stuff goes through SBIR and then through DARPA.
I think the Japanese thing is also very heavily driven with their demographics, and that's why you see the humanoid robots, a large aging population. That's why it's a very government-driven initiative over there.
Yeah, I just wanted to make a couple of comments. I work in IT security. I found it very disturbing overall, your comment about the robot not being rogue or otherwise, or, you know. I would love to hear a little bit more about it. I mean, we have systems that get hacked every day, every night. We have trusted operating systems. We have everything, and yet the problem is not solved. I'm sure you're taking it very seriously, but, you know, we've also been told in the past that our phone calls aren't tapped and we don't do torture. So I find it very, 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 I don't really believe it for 1 minute that this is just something you sort of look over and write 3 lines of code or put an extra chip and it'll solve the security problem. I think this is a very serious issue. I'd love to hear a little bit more about it.
Well, in my case, I'm not really working on autonomous robots that are running around. Robots in a very controlled environment. But in any case, the robot has to be equipped with some sort of bad stuff on it to go hurt people. You know, if this is, all it is a mobile thing that moves around and has a little claw on it, it can do some damage, but if it doesn't have a gun on it or doesn't have a biological thing on it which can disperse, it probably can't do much with it. So it's really the payload of the robot which determines how much damage it's going to do, and if there are no payloads on it, no matter how much you hack it from far off, you can put a payload on it. So there's some physical issues that prevent these things, and But on the other hand, a little remote car can be easily used by anybody to do a lot of damage and remotely control it. So,
Okay, here's another question for you guys.
Hello, thank you for your comments. My name's Ed Vaughn. I'm with the Department of Defense. And one of the reasons I'm here is to try to report back to my leadership on what the state of the art of ethics are in this environment. I'd like to offer to the crowd, I'd like to energize everybody to get involved in the ethical discussion. As you mentioned, the military, quote unquote, isn't going to use robots autonomously to kill people. But I would argue that that's a U.S. military-only decision. And so if you could please comment on how you think maybe some of the other nations, some of the non-signatories to Geneva Convention, et cetera, might handle it.
I don't know if I have any more insights than you do about what that would be. I mean, certainly in terms of Western Europe and in North America and in primarily Asian countries, I think they're going to be about the same. In terms of what other third world countries or second world countries or whatever, I don't think there's nothing constraining them to do exactly what you're speaking of. There isn't any. There's nothing there.
And just to follow up to that, then the folks, and particularly you folks that are you're the leading edge of these things. I don't know that there's another group anywhere holding a conference on the ethics of what you're doing, and I would certainly like to encourage that to be part of the cross-check. And I know it is, but I would certainly like to re-energize that. As a guy in the DoD, we oftentimes aren't the ones who can lead the ethical discussion, if you know what I mean. And so the responsibility lays here.
Yeah, so take the ethics discussion a little bit further. Earlier today, I think it was Bob Pisani who was talking about interacting with his intelligent agent on the screen. And was it you, Bob, who was talking about how it's going to be your best friend, right? Certainly, science fiction and a lot of people have been thinking about taking that kind of intelligence and sticking it inside a robot, and we start having real-world relationships with physical objects like robots, and that obviously. In fact, Trevor, when I was at your office the other day, you had some reading material in the bathroom called "Love and Sex with Robots," I believe was the name of the book.
Someone wrote that book and someone published it.
Right. So I know you guys are all businessmen up there, and you might not want to respond to those kinds of things. But can you postulate on what are some of the more interesting ethical issues that we're going to be faced with the kind of merger of more advanced artificial intelligence and robotics that may be coming our way in the next decade or 15 years? And do you have any opinions on if that's a good thing or a bad thing?
In my own humanistic view on life, I actually really hate the idea of people having robot friends. People should be interacting with people and loving and having sex with other people, and any robot we inject into that means sort of one less opportunity for a person to be having a real relationship. So I'm not going to contribute to that.
I guess as I listen to all these ethical concerns, the first thing that comes to mind is, I was in the software business and heard quite often, well, the computer screwed up and made that mistake. It's like, no, the programmer who created the code and decided how the data would be processed ultimately either did not anticipate that mistake or built that mistake on purpose, for some alternative motive. And I would make the same point about robotics. I mean, it will enable, in some cases, bad behavior for people who are intent on behaving badly. And if there are other countries that are intent on creating killing machines that are going to come out and do that, whether we sell them a sensor or not, that's probably going to happen. There's nuclear proliferation out there that I think we all ought to be really, really scared of. And I think that that's the kind of thing you need to monitor on, and you need to watch how these developments happen in all these various places and how they happen because of the intent of the people, not because of the fact that the technology has somehow run rampant and figured out a way on its own to to commit immoral acts. So that's kind of my thinking of it. And again, as a businessman, I sell a sensor that helps people see better. So if they tell me that they're going to do it to wipe out a city, then I'm not going to sell it to them. But beyond that, I'm not going to probe their ethics that much, quite honestly. I'm going to see if there's business there, and realistically to see if there's something that maybe can help improve. Like, for example, if you say, I'm not looking to enable the next killing machine, but if I can give you a better view of what's around you and not kill a civilian, then I've done good, right? If I can take a soldier out of a truck and not have them blown up, then I've done good, right? So there's two edges to this sword as you look and how these things move forward in this technology. I'm inherently an optimist, and I think it's a good thing generally.
Okay, what other questions do we have?
Not to distract from the engaging ethics question, but to bring it a bit back down to some of the larger singularity themes, which obviously ethics is an important component. In the past, the whole idea of creating intelligent machines and artificial intelligence back in sci-fi and then sort of up until recently, robots and physical intelligent beings that were human-like were a big part of that vision. And then as software has become a larger part of the equation, and we have the idea of the disembodied mind and the internet and the semantic web and virtual agents that can have human-like intelligence, it seems like there's been a little bit of a divorce between, what's going on in the robotics field and what's going on in the kind of more ambitious sort of artificial general intelligence. And of course, there's a huge movement away from traditional AI towards embodied cognition, and guys like Rodney Brooks, who I think has been here in the past, that makes the vacuuming robot that people make fun of is actual, I don't mean people make fun of it, but I mean that people laugh that it's not exactly what we think of as an intelligent machine, but he's actually pursuing this from the sort of bottom up, the idea that, the embodied robot and distributed systems with intelligence, the edges may end up leading to more advanced types of cognition. And I guess I'm just curious what your guys' perspective, being in the robotics field, is about, that coming full circle where the cost of robotics, things like nanotechnology, nanomanufacturing, will bring it down to where guys like Ben Goertzel that are using virtual agents to try and provide an environment for AI. Now we can actually maybe bring it back and say, come full circle and have robots combined with, the semantic connected web combined with an attempt to architecture intelligence. And basically, do you see your industry as playing an active role in that, or do you see yourselves as divorced from that endeavor? Sorry, long question.
I'm not quite sure what the question was, but I'll feel around a little bit. When you talk about Rod Brooks' work, one of the reasons why he was able to create a robot that looks as though it has some type of intelligence when it doesn't. It's incorporated into the form factor for the most part, and then some rudimentary intelligence. But using that approach, they're able to get something done that works, and they're able to keep their costs down for the Roomba vacuum cleaner. So for the most part, what I think you're going to see for these first generation of consumer robotics, and maybe even some of the other service robotics out there, is that bottom-up approach, where it's going to be less intelligence, a little bit more based on the form factor, sort of a bottom-up approach to those creating more intelligent robots. The thing I think you're describing is more of a top-down approach, where in fact there's a lot more going on in terms of what the robot is thinking and doing, and then it's using those for the decision processes as opposed to something that's more rudimentary. But right now, I think for the majority of the robots that I'm looking at, outside of some very, very specialized robots, they're taking that bottom-up approach just because it's cheaper, it's doable, and it gives them a chance to create products that they can sell into the marketplace. The price for that intelligence is too much for a lot of consumer stuff, and even for some of the service stuff.
Thank you. My name is Zachary Kidd, and just to try to track forward, maybe a mental thought, using Walmart as an example. If I can buy a Roomba in 2008 from Walmart, can you sort of tell me from a sort of robots we could buy in 2015, 2025, 2040 from Walmart?
Let me take a shot at the 2015 one, and I'm going to assume that Walmart sells riding mowers. Even if they don't, I'm going to assume that because I think it's an interesting example. You're going to buy your riding mower, and you're going to pay some amount of money for the auto navigation option. And you're going to take your riding mower home, and you're going to hit the learn button, and you're going to mow your lawn. And then the next time when it comes to mow your lawn, you're going to position the mower, and you're going to hit the play button, and it's going to mow it for you as you walk away. So it will capture your lawn, it'll store it, and it will replay it. And forevermore, as long as you don't move a tree, or even if you do, it will mow your lawn. And that's the type of thing when I say, how is autonomy in the vehicle space, which is where I'm the closest, how is that evolving? It's in the slow-moving autonomy is what we're seeing move forward, things like that. So you'll see security bots strolling around the outsides of power plants with vision and other types of things that will do that type of security. But that's the kind of thing you might buy at Walmart, is a repeating riding mower.
What you're talking, though, is about consumer robotics. Robots bought by an individual for their own use as opposed to a company. So I don't want to speak too much, but I suspect what you're going to find is those types of lawnmowers, and they actually have those things now. I have one at my house. It's not sensor-based. It has a wire, and it actually, you go in, and it'll spin around, and it'll learn, and it'll go back and charge itself. It's not great for the U.S. where you have big yards, but in Europe they're more popular. They have to drop down in price. But I think probably not by 2015, but by 2020, maybe a little bit before that, you'll start seeing that the personal robots being developed in Japan now, which are being created as sort of the nexus of control for everything in your house. They typically have a small humanoid form factor. They can recognize your face, they can speak, they can recognize rudimentary language. They're interconnected with the internet, they're interconnected with your television, they're interconnected with you away from the home, and that will be your nexus of control for a variety of things in your house and in your whole life. So instead of speaking into a glowing rectangular box, whether it's a cell phone or a computer screen, you'll be interacting with this other type of device that'll be able to move around the house. And companies like NEC, if you get on the web and look at Papiro, they've been working on that for 11 years now and putting a lot of money into it, millions and millions of dollars, working with the university and entrepreneurs to spin something out, which is a whole new class of consumer robotics product. So I suspect at that time you'll see that, as well as the lawnmowers, and of course, some more intelligent toys that'll interact with, they'll be connected to the web, you can download personalities, they can grow over time, that sort of thing.
So my favorite, my 2012 prediction, I think, for a robot that you'll find at Walmart is the paparazzi bot. And what it's going to do is you'll buy one and it'll follow you around and take pictures of you all day long. And then it'll automatically feed those up to your friend feed or your MySpace page, and basically like Twitter on steroids with videos. And when you go to a party, if there are multiple paparazzi bots there, then they'll network with each other, and you'll start getting these kind of third-person pictures from other people's paparazzi bots of you, and they'll trade images and all those kinds of things. I think it fits really well into the theme of the youth of today, who are very much into, sharing as much information about themselves as possible in as many ways as possible. So I'm betting on the paparazzi bot. If anybody wants to fund that, I can give you my business plan for it. Okay, I've got one question for you guys, and that is Peter Diamandis, who kind of created the X Prize Foundation, as you guys probably know, is speaking tomorrow at the summit about what he calls long-term X Prizes. And if Peter came to each of you and said, what should we create an X Prize for? When is the date, how much should we put into it, and what's the challenge? What would you say is the most interesting thing that you would want to create an X Prize for?
I can come up with one. Well, they have the one going to the moon, right? And you have to have the robot go out and send back a signal. They're already working on that in Carnegie Mellon and a variety of other universities. What I would like to see, and I think would really capture the imagination of the world, as much as the Grand Challenge, or even more, because you're not going to be dealing with cars, is to have a humanoid race 100-yard dash with two-legged humanoids. There's already, in Japan, they're working, and they said by 2050 they'll be able to create a team of robots, two-legged humanoids, will be able to compete in the World Cup. I don't know about that. I mean, 2050 is not that far away. But to actually have a race with two-legged humanoids, 100-yard dash, winner take all, $1 million or whatever. That I think would be really cool.
Mine would be the first, of course it's related to autonomous vehicles, which is what we do, but it's the first company that can create a race car that can beat the fastest time around the Indy 500 track autonomously. So you get a human driver, and the human drives the track, and then you have to beat that best time. First person to do it's $1 million.
Yeah, now I seem to remember somewhere where somebody was talking about like having a robotic NASCAR kind of competition.
Yeah,
something
that's
like-
all coming.
That'd be cool.
There's rumors of a very large internet-based company around here sponsoring stuff like that, but I don't know anything about that, so we'll see.
That would be you, Trevor? Yeah.
Yeah.
Got a next, yeah, go ahead. Chetan.
I have a 3-year-old, and the only thing that engages him for a long period of time is TV. And I'd like a robot that X Prize that can engage a 3-year-old for a whole day without any interruption. I love that.
I say that they should get $1 billion in there.
My question is regarding AI and robotics and regarding neuroengineering. Like these days, like recently in University of Leeds, they made a robot like similar to WALL-E, the Disney movie, shaped like that, and which runs using 100,000 neurons, which is like a neuroengineering, like neuron interface to the robots. And the robot develops its own personality at a very basic level right now, based on the experiences that it gathers. So I just wanted to have your take in terms of business and in terms of AI in robotics, as what kind of implications it has, or what's going on in that direction right now.
So in terms of adding intelligence to a robot, a WALL-E-like intelligence to...
Basically, like in University of Florida, they did this experiment in 2004, which is very popular, is that you use 25,000 rat neurons to fly a simulation, and then recently they did the same thing. Like it's a robot shaped like WALL-E, that's just marketing, but it's 100,000 neurons which is driving the robot. So it's not like AI in software or neural networks or genetic algorithms, rather real neurons. So what kind of an implication would that have, and how much of that is in the industry at this moment?
Well, there's been that study and other studies where they've been driving robots, and including groups of robots with rat neurons, and also studies where they were able to run. I think the biggest one, the most well-known, is coming out of Duke, where they're able to run mechanical arms through monkeys that are directly attached to the cerebral cortex some way. So I suspect the way that that's going to play out in terms of products is devices to assist this disabled somehow. And you're already starting to see that with embedded things within legs. I know at Boston University they're doing work there, and other things. I haven't seen anything with direct implants controlling whole arms as opposed to, say, a mechanical arm, but I suspect that's the next step. So you do see the basic research, the core research coming out in the areas that you described, and I suspect it'll be they'll create these devices, mechanical or otherwise, will interact directly with your cerebral cortex. Neural implants.
I think it's unlikely, though, that we'll ever see that the riding lawnmower that you buy at Walmart comes with a little blob of neurons in it. I think that technology is not going to be used to add intelligence to otherwise mechanical systems.
Right, but at the same time, like you know that average human being, for instance, has 28 billion to 30 billion neurons. And yet right now we are trying to do 100,000 neurons, and the robot is going to do simple things. I'm just trying to see if we keep on, as technology proceeds, if we go on 100,000 to 1 million to 2 million, we might reach a stage where we start seeing things emerging out of their own, right? Because the system that we are using, neurons, is not something that we made. It is already existing in nature. So the only thing I wanted to get on is, since we're talking about AI and robotics, and in software we don't see that happening, it's really rudimentary. But in this way, can you see a future, instead of, 3,000, and, can we have something in 2025?
You are starting to see, I think there's 1 or 2 companies that are doing hardware-based systems. So I think Recognitics, I believe. So they have a whole, basically they're mimicking the way neurons operate. You have to teach these neurons how to operate. It's all done in hardware because it's faster and it tends to handle complexity better than some of the software-based solutions. So you are seeing that. I don't know where that's going to go though in terms of incorporating them inside robots. They're just starting to do that now. These are very small hardware startups coming out of a number of different companies. The one that comes to mind I think is Recognetics. I could be wrong about that. It's a French and US-based company.
Okay, I'll wrap up here with one last question for you guys. I think that for the long-term success in the United States, we need to continue to focus on fostering innovation. I think that's been, a major secret to our success over the last 100 years or so, being, the world's leader of innovation, of technology. And I think at the same time, having 4 kids myself, I think the kids today like to use the technology, but I'm not so sure that they're also excited about careers and things like we're involved in and so forth. So what advice do you guys have? What do you think we should be doing from a policy perspective, from an educational perspective, from a home perspective with our kids, to try and inspire the next generation to take up some of these big challenges that we've got both in the robotics space and in the larger, accelerating technology field as well?
Well, in terms of engendering a love of engineering?
Yeah,
within
and
them?
innovation.
Innovation within them?
Right.
I can't speak so much for innovation, but in terms of teaching people, mathematics and computer science and working together in groups and other things, there's a big, huge push on throughout the world, North America, Europe, Asia, of using robotics as sort of that tool to do that. Trevor and I were just talking yesterday about how this model is following, in many ways, the PC model of the educational robotics model. So when you were talking earlier about where I see growth in the marketplace, certainly the military, medical, but in consumer space, educational robotics marketplace is going to be huge because people realize that it's useful for teaching these other things. So I think any effort that you can put there's businesses there. No one owns that space yet because you have the software side, you have the curricula side, you have the hardware side. So just fostering a love of engineering and sparking interest using robotics is one way to do that. And there's a lot of different initiatives in that area.
I'm always reluctant to worry about the next generation, that there's something that we consider very important that they seem to not find very interesting. My great-grandfather worked with steam trains. He did a lot of, was an engineer and designed them and drove them. And I think he was disappointed that his children thought that steam was kind of old hat. And if our children are finding that a lot of the sort of IT software stuff that we think is important is boring, maybe it's because they're on to the next thing.
And actually, if you talk to people who were big into NASA and going to the moon, they were finding that they were disappointed with their kids because their kids were interested in dinosaurs and robots, not interested in space. So it's always, something else.
I get down to some very basic premises of that. You need more funding for schools for science. And it's just, these schools are underfunded. They don't have enough interesting programs to engage kids, to get them involved in science early in their lives when they're little sponges. And I don't think there's enough coolness to science in general. If you leave it to its own devices, generally the nerdy are excluded from many of the cool social events, and I think that is a dynamic that we ought to try to work with, right? They have little opportunity to seek and mate. So, that's a stigma. That's a problem. I think that stigma has advanced, and I think it's hurt this country terribly. I think it's horrible that people have this stigma. I think it's terrible, and we should work as a society to celebrate those that pursue science and software and robotics and whatever, chemistry, whatever it is, that should be celebrated. And it can be dreadfully boring to be taught. I think a lot of the teachers are way behind. They're not up. This stuff moves so fast, now. I mean, we can grow new sensor designs in 2 hours with our 3D printing machine at work. And the schools are not keeping up with what's new and what's interesting. So I just think there's so many just basic fundamentals of funding and society making it cool and parents focusing on it and that we can do just today, literally, to try to improve this problem.
All right, with that, let's thank the robotics panel.